Welcome back to the last session of this conference. The last days we heard a lot about PFAS, about the potential health impacts. Mr. Hendel started the conference by using the image of James Bond for the PFAS. So we were talking a lot, and we are still discussing how we get to see through the game of this double O agent, or perhaps better said, multiple F agent. We will discuss a little bit about how to structure research to better assess the health risks, but also to make sustainable policy decisions. My name is Frederic Müller. I work here at the BFR. I'm head of the BFR Academy, the event organization unit of the BFR. And I will start by presenting our panelists. So, first of all, unfortunately not on site, but you just heard her presentation, is Xenia. She's Associate Professor of Environmental Analytical Chemistry at the University of Copenhagen. Her research and interdisciplinary expertise combines laboratory methodology with a strong commitment to translating science into actionable solutions in the fields of environmental chemistry, regulations, and public health. Next to me is Carlos das Neves. Carlos is a member of EFSA's senior management team. His areas of expertise include animal health, food safety, wildlife, emerging diseases, and One Health. He has led national and international research and development projects and has been a member of international panels and organizations related to his field of work. Next to him, Matthieu Schuler. He is the head of the Science Expertise Division of the French Agency for Food, Environmental and Occupational Health and Safety. He coordinates the departments responsible for risk assessment, health alerts and vigilance, scientific research funding, and the social sciences expertise and society unit. And next to him, we have Jorge Herremans. She's the PFAS coordinator at the Dutch National Institute for Public Health and the Environment. She oversees the RIVM activities on PFAS biomonitoring, risk assessment studies, and guides scientific research on exposure and health effects, and leads communication efforts to inform policymakers and the public about PFAS-related tasks. And next to her is Jorge Numata. He is a senior scientist here at the BFR, where he specializes in mathematical modeling and toxicokinetics with a focus on transfer of substances from animal feed to foods of animal origin. He also chairs the EU member states PFAS initiative group, risk assessors team. And last but not least, Frans Verstraete. He is a senior expert at the Directorate-General for Health and Food Safety at the European Commission. He is widely regarded as a leading figure in European and international feed and food safety legislations and contaminant risk management. He regularly collaborates with scientific bodies such as the EFSA. Okay, so now that you know everybody, we will start with one question to all of them, so a round where everybody can give a short statement. And the questions I want to ask, and I think I'd start with Xenia, and after that we just go the round how you're sitting here. The question is, what are the most pressing challenges in PFAS risk assessment, and how do we approach these? Xenia.
Thank you very much, and again, thank you for the invitation to be in the panel. I would say, as I just said in my presentation, the most pressing challenge is that we have so many and so diverse PFAS, and we still have very little oversight of exactly which PFAS they use where, and we have a hard time generating the data, both when it comes to hazard data and exposure data. A little bit more specifically, I think also data for the very volatile PFAS I see as a pressing challenge, both generated in the production, manufacturing, and end of life of the PFAS. They can be emitted from production side or manufacturing sites, but also in the recycling and end of life. And here we need better methods, and we have this challenge also with the GCMS methods that it's a little bit challenging identifying these compounds. So I think we need more work there. So I suppose this was just a summary of where we see the most pressing challenges, right?
It was. Thank you a lot. And Carlos?
So thank you very much. And first of all, very good morning also from myself and from our colleagues in EFSA. And thank you for BFR for the organization. I mean, I think it will come without a surprise that for an agency responsible for doing science-based risk assessment, the biggest challenges continue to be linked to, do we have the science we need to get the job done? And I haven't been able to follow all the presentations, but some of my colleagues in Parma are following, and they keep WhatsApping me on some of the messages that many of you have already conveyed, that we have gaps. First aspect that I think is key, we still have gaps. Not surprising also, as I always feel this, the number of PFAS is a little like the stock exchange. It changes every day, 7,000, 14,000, 10,000. But anyway, it's always on the 1,000, which already is daunting. So real gaps in knowledge, and we can discuss, I'm sure, a little during the panel today, what are the most pressing gaps. Then I have two more big challenges. The second challenge, on top of having the scientific information we need, because there are too many, you don't have the methodologies and so on and so forth, is translating that science done by academia, by research organizations, by industry, into something we on the regulatory side can use. And this is where comes the challenges of methodology development, harmonization, validations. So making sure that we can translate that knowledge into something we can practically assess and use, which is not just because, I like to say it's published in Nature, that we can bring it into and change the risk assessment next day. So this is the second challenge. And perhaps the third, and this I would also add, the harmonization, means how do we team up together? Different organizations have spoken for the last 2 days, everyone at full speed doing stuff. Hopefully, these ones link, they don't overlap too much. I pray they don't contradict each other. But anyway, harmonization. My last challenge, how do we make sure that whatever we discuss here is understood by everyone out there? I think everyone here is on board, thinks this is serious, everyone likes it. But there are millions of consumers and citizens out there that need the right information. And unfortunately, the right information is something more and more scarce these days. So this is another aspect that for us, risk assessors and also responsible for risk communication is key. How do we explain to people what we know, what we don't know, and how far can we actually tell them something? I stop here. Thank you.
Thank you a lot. Matthieu?
Thank you for the occasion to share thoughts here with this nice panel and also people taking place in the conference. Maybe some thoughts. We have started with films, so I will continue. The main challenge for me is to avoid to be drowning by numbers. We have just finished the work at ANSES. We analyzed more than 2 million data. We thought we did a great job, but in fact we only touched about 134 PFAS, so more than 3,000 left. In this, to that respect, our commitment as experts is to be able to see and to identify. We have already known who are the good, who is the bad. Now we have to find the uglies, about the 3,000 remaining. And there, probably we can, of course, develop the usual toxicological or epidemiological approach, but it will take a huge time. So we have to find other ways. Some thoughts about that and some priorities, I think. One of the common properties of PFAS is that they are very stable, not as themselves, but if they divide, it's again a PFAS. So probably what we should focus on is also to find whether all PFAS are finishing in some common end metabolites, ultra short chains and other ones, because this one maybe we need more focus compared to others. The other point is we have already data existing. We have had a nice presentation yesterday about epidemiological study. And why do we have data? Because we have environmental presence for years, and we have also health data somewhere. So probably there is here a need for connecting them together to learn whether there are real health concerns. And that we have also to quantify and identify beside the usual track of toxicology and epidemiology. And these were, I think, the first challenges that we have. And then, of course, we still have this restriction process going on, which have to be supported to come to an end. And after that, of course, the restriction brings us to think at PFAS like a family. And that's totally correct when it comes to restricting their use. But now the question is, we have plenty of chemicals, plenty of PFAS in the environment, but there are other persistent chemicals in the environment. Do we have necessarily to think at them as a family, or do we have to consider all persistent pollutants together?
Thank you. And Jorge?
Thank you very much. Good morning to you all, and thank you for the kind invitation and the organization of this event. And I think this event is partly uplifting because we heard that the levels of legacy PFAS are dropping, but it's also depressing because there's so much still to do. It seems a huge burden, but it's good to see that we are all together, and I think that's the way forward. And one of the challenges that we keep together and share the information on PFAS, and amongst scientists and regulators. And I pick out two challenges, and one is that we need to know the health impacts of the PFAS existence around us. Because PFAS are here to stay, that's what we all know, and then the regulators need how much this information to set priorities on PFAS reduction programs. And for a good health impact assessment, I think we need merely everything which was said the last 2-3 days. We need the analytics, we need toxicity, we need harmonization in mixture risk assessment, and so further and so forth. So health impact assessment is one of the challenges. And the other is the risk communication. It was a bit touched upon by Thor that how to explain to the public at large that if you are above a health-based guidance value, you will not drop dead tomorrow. But how to put this in perspective in nice words that people feel safe and feel that they are in control of their PFAS exposure as much as possible. So 2 challenges and, well, a thumbs up for everyone and keep on going.
Thank you. Jorge?
Yes, I am overwhelmed by the amount of good talks and good information that we have been listening to these last few days, and how much insight that gives us into PFAS. So because my work is very centered on risk assessment, I think that this lemma of no exposure, no risk should be one of our guidelines. Of course, we look at this huge variety of PFAS that the industry is putting out, but at the same time, looking at the internal exposure of humans, I think, should be one of our guiding principles. And this can come either from the bioaccumulation properties or from a very constant exposure of things like TFA, for example. So I think one of the most important things that we should keep in mind is the movement of PFAS in the food chain, like to understand how this happens. And so when we think about like the eggs and the meat in the supermarket that may contain PFAS, following this back, we will look at all the components like the animal feed and the water that the animals are drinking, the soil. And this connects us back to the environment that these agricultural systems are embedded into. We know that ultimately the PFAS in the environment are coming from the industry, passing through many stations, even through consumer products or industrial processes. There, we also listened to a talk about the restriction proposal, which of course is a marvelous thing. And however, even if the restriction proposal could fulfill its maximum impact, we know from the lesson of PCBs and many other legacy chemicals that the problems will definitely not disappear. They will accompany us much more. The strategies in any one of the steps from the industrial output of PFAS all the way to the consumer plate. All the strategies to stop the PFAS in any of those steps are valuable, and we should continue doing research into doing that. Besides the research that we do to understand the hazards, we should also do this research to know how to put blocks to these PFAS flowing into our consumers' plates. And, of course, the water taps. So it obviously has worked to a good extent for things like PFAS. We have seen these declining levels, but we need much more than this.
Thank you. And last but not least, Frans.
Yeah, thank you. Well, as you are aware, in the EU we have legislation on maximum levels of PFAS in food, and we legislate what we commonly say the EFSA 4 PFAS, which indeed were the basis of the EFSA assessment back in 2020. But then, of course, when we look into the EU legislation, we see, for instance, the parametric values which are set in drinking water, also will set in groundwater and surface water. They include the sum of 20, sum of 24, or total PFAS. Of course, they are sometimes they have not necessarily only a health-related basis, but they are mostly also perceived like this as a health-based value, and so an exceedance might result in a risk. And so it is important, it's for me not easy to explain, well, we say why we regulate only the 4, because it's based upon the EFSA opinion. But it's not easy to say why is then in the drinking water 24 PFAS is regulated, or the total PFAS. So this is, there should be a bit of more, I would say, narrative on what is indeed explaining this difference. Of course, it's from a risk management point of view, but also, I would say, the colleagues from DG Environment have setting the standards have also had input from the science. So why, indeed, is there this divergence? Secondly, and there of course, we base our levels of the EFSA opinion, but we have already heard it also earlier this morning in the conference, and also within the Drinking Water Directive PFAS levels, they apply also their relative potency factors. And we hear it here very much in EFSA. In the EU regulation on feed and food, we are not applying any relative potency factors. It's addition. We have also for the total of 4, but it's just an addition. And that's also based upon the EFSA opinion. And so it is important that within the coming years, because we foresee a significant review of our EU legislation within 1 or 2 years, that indeed there is also clarity as regards these relative potency factors, to which extent do we have applied them like we do for the dioxins with the toxic equivalent factors? Do we have to follow in the future a similar approach for PFAS, yes or no, in food and feed? That is also an important challenge, I think, for the risk manager in the future. Thank you.
Thank you. And after this first round, I guess we're starting with the discussion, talking a bit about the science and evidence of the health risks. How do you see the evidence of the epidemiological data currently available in comparison to the animal studies? And how do they support each other? Perhaps Jorge, couldn't you say? Yes, I can. How do you see the evidence of the epidemiological data currently available in comparison to animal studies?
Thank you. We think there is, I'm not sure where you're hinting at, but we have the epidemiological data which are used for health-based guidance value. And in animal data, we see as well the immunological responses. So we see some overlap. And I think we need both to improve our knowledge, maybe in addition to the NAMs still developed, because we need insight in the method of action of the PFAS. We're still in doubt there. So I think it's all additive. It's not maybe where you were looking at, but this is.
Yeah, Matthieu?
Maybe I think we have too many PFAS to discard any kind of data that we could get from science, both toxicological and epidemiological. And of course, when they are somehow questioning, then it's a food for thoughts on how to understand better their behavior. And again, I think what we need is probably a new generation of the use of data. Again, one of the particularities of PFAS is that they have been used for years, not since yesterday. So there are places around some cities, within some regions, where they have been present more than in other places. And this is why I think, and it has been shown yesterday in a nice talk about some cases in the US or in Italy, but when you take each of these cases, you do not have a sufficient epidemiological power to draw clear conclusions. So now there is a need probably for, there are already conclusions, they're robust, but limited to the power of the number of people concerned. So there is a place for new data by pooling them, and also by confronting environmental data that we are able to gather and health data. Because there is probably, if we have sufficient data, so the use of massive data can bring us new information and learnings.
Thank you. Yeah, Carlos, of course.
No, just very quickly also from my side. I mean, when you ask how they relate, I'm of course going back to the opinion of 2020, and I even speak, I see Ron here, so I speak under control. I think on that, already at that level, we saw that they confirm. Animal studies confirmed what we saw also on the epidemiological studies, and but it also revealed, like even at the TWI that was established, showed that we may have indeed a population that may be beyond what should be happening. And this highlights already one thing, that while the values seem to agree, 4, indeed, Frank, sorry, we went from 7 to 100 to 27 to 4. First, is this 4 enough to conclude? Yes, but could we do better? Probably yes. Number 2, if there is indeed TWIs that are being surpassed by groups of the population, a good push for more epidemiological studies that may help to strengthen and broaden this knowledge. And last but not least, the discussion on the animal, of course, studies that are available and to which degrees they are still the best available models, aware that also there are different behaviors on these PFAS in different animals, and that as well could raise the question on how good they will come to match as we do this again and do this for more PFAS. So I think that's what I can try to add from my side.
Thank you. I think I just take up on this, because yes, more PFAS. How can the data gaps for poorly studied PFAS be addressed? What role can analytics, read across, or other alternative methods play here? Perhaps that's something for Xenia to answer, or to start answering at least.
Yes, thank you. Well, I think we should try to request, and here we really look at the authorities, that we have a repository for the standards. We could start with technical blends. I know there are many analytical labs that have each their little collection of standards, but could we get these into a more secure and harmonized collection of standards? Then I think we could start from there to actually help identify some of the compounds that we find. I think also in general we should consider accepting to use the non-targeted data, even if that's semi-quantified, but also use it as a way to assess the frequency of detection. How often do we find them? This can help us to prioritize which ones we really should focus on. And then I think we should also further develop the systematic gap-filling methods, so we do not discard the data for all these other compounds that we do not have very solid data for. I think also a strategy could be to investigate closer to the sources, where we know that we have higher levels. This really helps our identification of the compounds and the detection. And this could be closer to all the many sites that we saw being registered in the PFAS forever pollution project. So we have a lot of knowledge of where PFAS is produced and used. So going close to the source, analyzing in the products will help us to identify these compounds and have an idea of which ones we see more frequently, so we can prioritize which ones that we think are most risk to human health. And I think this prioritization is really something I would agree that we need to do. I think, unfortunately, if we wait until we see it in human blood, which is typically takes a long time for PFAS to end up in human blood if it comes via the environmental route, it can be we are a little bit late, and the pollution may already have spread. So therefore, I would more go towards close to a source. It could also be wastewater treatment plants, as done in Park. And then a systematic choice of which PFAS that we generate data for, so we can fill some of this data gaps in the experimental space. That will help us to build the models to do the in silico hazard assessments. I think those would be my suggestions. Thank you.
Thank you. Yes, I see Jorge.
Yeah, thank you, Xenia, for contradicting me about the blood first approach. Yes, you're right. There is a delay there, especially with bioaccumulative substances. One thing that I would like to add to your idea, your proposal of looking at cartography of sources, and is that one on top of that can add environmental fate modeling and the aquifer modeling and to model really the mobility of these substances in order to have better predictions of where to look and where to really find these substances.
Thank you. Any other thoughts? Yes, Matthieu?
Just add,
Xenia, okay.
Yeah, sorry, to come back to Jorge's point there, that I think an advantage of going close to the source, and I agree also, modeling the environmental routes, but an advantage of going close to the source is that for a regulator, it means it's much easier to manage. If you know that this is the source, if you see it in blood or in biota, bird eggs, etc., it's very hard to do a source allocation. But having this combined information about what is it in humans living near a polluted site and what do we as the source, this can help to address and prioritize the actions to limit the exposures in the first place. Sorry for interrupting. Thank you.
I do think those two things are not contradictory, because the approaches in order to help populations in hotspots are not the same than the ones we have to follow for the general population. Also, I think there's complementary.
Okay, so go more, or you want to add something, Carlos?
One thing on the data, perhaps not on the type of data, though what I hear makes a lot of sense. That some types of data that we've been missing, environmental fate, I heard, transfer along the food chain, I also understand has been highly talked already in the last 2 days as a gap. But I want to address another aspect of the data, which is the old share is care. And once you generate all of this, do we have the right tools to ensure that this data is available, it's interoperable, is retrievable, is reusable? So the simple principles. A lot of efforts put in there. We have now a dream of a common data platform for the union. But I would highlight, thinking of a lot of scientists that are here in front of me, the amount of data generated by research activities in the union, just not to go further than that, we need to be sure that that is somewhere we can use it. And that is unfortunately not always the case. It's not the reality of Park, who is indeed working, and I think we will know where the Park data is and how we will keep it alive and hopefully be able to use it. But there may be many amazing Horizon Europe projects generating extremely interesting data, published, and then lost in some Excel file in a supplement to a journal or in the hard drive of a first-class PFAS researcher at same university. And until we solve this problem, we keep having a problem. So I would strongly appeal to share is care.
Yeah, that's a good point, of course. And I mean, all of us, we need to use this data, but of course the management does need this data. So a question for you, Frans. How does the current scientific evidence on PFAS health risks affect the prioritization of regulatory measures by the Commission? And what are the implications for the Commission's approach to this issue?
Well, in fact, okay, if we have scientific evidence, then we regulate. So that is the reason why for the EFSA assessment back in 2020 with the tolerable weekly intake of 4.4 nanogram per kilogram body weight, with the exposure assessments, it's clear that there is a potential health concern. And that's indeed the trigger for regulating it. We regulated indeed the 4 PFASs which were identified to be from EFSA, for which a risk assessment could be performed and which were considered of concern. So that is the basis. Of course, we know and we hear all the other PFASs, and so from the moment indeed, and I understand that EFSA, and we will possibly maybe ask EFSA anyway to have for an update for a PFAS opinion within 1 or 2 years, and I understand that EFSA also will have a seminar on the 17th of November on a state of the art to see, okay, if there is maybe already sufficient evidence around, because that is exactly what Carlos exactly said. There is a lot of science out there, but to which extent is it useful for regulatory risk assessment? That's always the big gap. And once indeed we have an updated opinion, then we can, of course, look into indeed the update of the risk management measures. Of course, we have, for the time being, regulated mainly the food of animal origin and fish and fishery products. Of course, we know that the main part of these, of the levels in the food of animal origin relates also to the feed. So we will have, and we know there are these transfer models. But of course, the issue is, and that is what is a bit lacking, is indeed, we know the transfer model, so you could translate the maximum level from that we have set for eggs and so on into what would be the level for feed. But what is lacking is indeed a sufficient large occurrence database on levels on PFAS in feed to really also know to which extent, well, of course it is feasible and achievable, because my experience with dioxins is that we have set levels for dioxins in food based upon occurrence data in food and on the P95. In feed, we did the same. We did also set levels in feed, also based upon occurrence data in feed, based upon the P95, as low as reasonable achievable. But of course, I get regularly the criticism that indeed, if you look purely to the transfer, that the levels in feed are not protective for the levels in food, because you could have a compliant feed, which results in levels of food higher than that. So, but yeah, that is a criticism I got, but I'm not fully agree. But it is important that we have as well, I would say, on a global basis, if we indeed have sufficient data on food and we can set a level as low as reasonable achievable on food, and we have also a lot of data on feed, and we set that also on as low as reasonable achievable, you know that currently these on a more global basis do correspond, because you have the levels in feed. The current problem is that we have not this data in feed, because feed is mainly also plant-based, mineral-based, and we know there has been in the beginning a lot of issues with analytical technologies to have sufficient sensitive methods of analyzing. And we have that also in food, where we had, okay, in food of animal origin we could set levels, but in fact the data which were available on fruits and vegetables, they were all below the LOQ, but they were not sufficient sensitive to really see if there is a risk related to the consumption of fruits and vegetables contaminated. So there is also their work to be done on this analytical aspect, mainly also for foods and feeds of non-animal origin. Thank you.
Thank you. I see a lot of people here want to contribute. I think Xenia was first raising her hand. So perhaps if I don't see you raising your hand, just give a sign the other way.
This was a comment on the FAIR data, so the findable, accessible, interoperable, and reusable data. I think I can very much agree that this is what we need. I think what we still need to resolve also for the open data for the common data platform is how to treat non-targeted data, because having been part of IPChem, it only accepts the very quantitative data. So it means that we are limiting ourselves to only the data for which we have standards. So I think this is still to be resolved. The Norman network does take in these data, but again, there are some fundamental decisions to be made on which data you use for which risk assessment. So yeah, I think it comes back to solving this question. But it is also a challenge for many research projects that it takes time to put them into the data platforms, and often there's not, it's not all the parameters that are relevant for a study that could be fitted into these platforms. But I think at least a starting point would be to have the metadata. So I think that could be the minimum requirement, and then at least in the future we will be able to find the data. Thank you.
Thank you. Then there were Jorge and Jorge.
Yes, I would like to react on the point where the data availability steers the risk management. And indeed for food and feed, it's the EFSA opinion. And the other scientific panels here, they are in favor of the RPF method, and this resulted in the framework directive taking over the RPFs in the most recent state. And I think, well, the environment is where exposure for feed and food starts. So I hope in future this will all come together in a happy family. Yes. So I think the one substance, one assessment of 10,000 substances, one assessment can be reached for PFAS. I think that's the challenge.
Thank you. Jorge, do you still want to? No. Okay. So then move on, because we don't have so much time. Again, Jorge, you were talking about communication as one of the challenges. So perhaps talk a bit about that. What do you think are the most pressing gaps in current risk communication strategies about contamination for consumers and industry? And how should policy approaches be adapted to bridge these gaps?
Well, in communication, we have really the challenge how to communicate the risks that we calculate and we understand to the public. And I think I can recall what happened in the Netherlands when we studied the homegrown eggs in the Netherlands, and we presented the news that you better not eat those for your health just before Easter. You could say, well, there you made a huge mistake. We had the data available, and we thought, well, when eating one egg, you already have far more than a weekly portion of PFAS in your diet. So then you still have to start eating and drinking. So it was very difficult, and we thought, well, we can keep it behind and wait months after Easter, but then we would get the criticism, you knew this, why did you tell us? So the timing is important. But the other thing is taking into account, what does it mean for people to hear this? Eating an egg from your backyard is far more than just taking the nutritional value of an egg. It is your feeling of having your own homegrown egg, and gives you a good feeling. And now we were disturbing this, also for people living far away from industry. So that's an example of where you can go wrong. So we have to understand what. So we need to connect with the social sciences on what it means those words, hazard, risks, and what can you do in your daily life to lower your risk, or how do you deal with a risk you can't change? So that's what I think we have to do as scientists, connect with the social sciences. Although you're not used to their languages and to their principles, try to bridge the gap. We need each other in doing this. And you also wanted to connect this to policy?
Yeah, I mean, the management is doing a lot of communication, so the policymakers do need to communicate too.
Yes, well, they have to be honest that there is a risk. Don't neglect that there is a risk, but give the right perspective with it.
But here I see Carlos and Matthieu. Yes,
yeah, just following on what Jorge said, I think also what is important is when we communicate is to qualify the risk, because as scientific people we are more and more precise. We are defining safety reference values based on earlier signals within our bodies, and but we did not change the name. That's the exchange that we had yesterday about the using immunotox toxref values. In this case, for the risk manager and for the population, is still an override of a border between no risk and risk. But the risk has changed. It's not the same type. The intensity, the way it will occur is not the same. And so that is probably where we do have efforts also when we communicate from risk assessor to risk manager. If the label is still the same, the meaning is not the same, and that's also something to be accompanied. And also to follow up, we have experience in France about chlordécone in the West Indies, which led to the same types of situation that Jorge has described about the eggs, because the chlordécone is there for a long time, just like PFAS, and also you find them more in the homegrown food. Nevertheless, it's possible, as just Jorge said before, to find ways and to change the way people grow their hens and chicken, because if you cut the path between the soil and the contaminated soil and the hens, then you can decrease and you can act. And it's important to give, I think, people the feeling that they can act on their exposure, so on their fate.
Thank you. And Carlos?
Thank you very much. I think a lot has been said, but this is actually also a topic which is part of the mandate of EFSA, of course, risk communication, where we spend a lot of efforts. I'd like to highlight perhaps 2 or 3 elements which I think are very important. And we see this also from the work of our social scientists, which we have in the house. First, realize, I would say, we'll communicate to the population, very different types of population we need to communicate, very different needs, very different sensibilities, knowledge. So there is not a message that you can just say, this works for everyone. So there is an importance of adjusting the message to the audience at hand. And this is important to be done. Second element of communication, you don't do it at the end after 3 years of working on an opinion and then launch it like a bomb into in the ground. We need to more and more, and this is part of transparency, and I think of a very also digitalized society, to bring people on board with this process. So people need to be able to follow up almost in real time, and this is now part of the transparency aspect of the work we do with the risk assessment. People are able to follow, if they are interested and want to know about it, how things are moving forward. So they can actually follow the story and not just be forced to consume it at the end. And this is, and the last point, which I think we're trying our best with our sister agencies, EU agencies, but also with the national risk assessors like ANSES, like BFR, a little bit of a united message. because it's very difficult for the audience out there to hear. I mean, this both at risk assessor and at risk management. It's hard to hear. Frank says 4.4 nanograms per kilo, you're safe, and then comes the GNV in the environment, 0, everything is bad. I mean, this is difficult for the person out there to understand, and it will be just as difficult if, and they don't know TWIs and ADFs, and not even I always know them, I confess, it's not my field. But if I go with 5 and ANSES goes with 6 and RIVM goes with 7, there may be very good scientific reasons behind this, and we know it's called divergence, it's called science. We don't always agree, but to the people out there, this is a nightmare. I mean, it looks like we are all just have a lot of free time in our hands. I'm sorry if I want to be a little ironic. So we need also to team up into giving a united message that resonates across. We are called the European Union for some reason. So let's unite a bit in the message we give, aware that there may be different things all the way from the north of Sweden to the bottom of Greece. But let's team up a little more also in risk communication.
Thank you. Yes, and look bit into the future, and Jorge, you were stressing about the food chain and the movement of the PFAS. So what do you think, what research is needed to look more into that field?
To also build on this message of international cooperation, I think research into the transfer of PFAS in the food chain, movement in the food chain, is becoming more and more coordinated throughout Europe. And I think this is, of course, very important because this research is expensive. And to do the experiments, expensive to model, and to get the knowledge usable for everyone. But through different European projects, and also recently also through the AF PFAS initiative group, it has also been very fruitful to have this kind of communication and to have increased communication among the European Union agencies working on the food chain transfer, and also, of course, many other topics regarding PFAS. I think we are in a much better place if I just compare with 5 years ago or 10 years ago, with how much we know about transfer in the food chain. We have closed a lot of those gaps, at least for the legacy PFAS. More than the EFSA 4, but less than the 14,000. However, we are in a pretty good place, I would say, and we will be in an even better place soon when we have the results of all these projects that are happening right now in the Netherlands, in France, in Switzerland, and in Germany, etc. So we're in a good place, I would say, understanding transfer in the food chain.
Thank you. And what research priorities do you see looking on PFAS? So I already get a from Carlos. So perhaps you start and tell us about the priorities in research you see on PFAS?
I'm not sure it's priorities, but we are on our way to Christmas. So in EFSA, we have a big Christmas list that my colleagues would like to see scientists to help us with. Running the risk of forgetting many, but I think also in the last 2 days, several have been mentioned that before Frank asks us for a new opinion, I think we should really look into, and I know many have been mentioned. Analytical methodology, while we are very good in some of the traditional old PFAS, there might be emerging things where we may be missing analytical methods. When we come to the toxikinetics and toxidynamics, there are still gaps in knowledge in some of the endpoints, the time, the mammary gland. I mean, there's several aspects here as well where we can go further. That brings us also to the discussion of the epidemiological studies, where we may need more data, aware that we are above the limits, as we've mentioned. You already mentioned the food chain, the transfer along the food chain, and the environmental phase, other areas where knowledge needs to improve. Before an opinion, so we don't do just 4 all with the same potency factor, we may need to look into the potency factors that have been widely discussed here. I know PARC colleagues are doing their best now to try to help sort out this issue, looking at the critical effects, the immune aspects. So let's hope PARC succeeds and takes us further. That's another one. A few more, as I said, I'm looking forward to Christmas. I would also say the mixtures, the aspect of mixtures, and the aggregated exposure. If I move also now to the exposure front, how to do it first methodologically, how to get the data, how to interpret it. And perhaps also, last but not least, and I also think it's been discussed in the last 2 days here, new methodologies. The power of NAMs to help us move quicker, and especially when we have 7,000 of these or 14,000, and even if you group them, which I heard is also a challenge. But how and when can NAMs solutions be put in place? QI-Vives, PBKs, I mean, there's a broad range of things now being developed. Remember that once developed in science, I can't use them. I still need to validate them or qualify them. So there is a process there to be done. But this may also be another tool that can really help us to perhaps get quicker there. So yeah, I think these would be some of the research needs that my colleagues would really hope get sorted out. The quicker the better, preferably before Frank wants another opinion.
Thank you, Carlos. So there were a lot of priorities already. Does somebody else want to add one or pick some of these to stress them out more? Xenia, yes, please.
Yes, thank you. I think it's also useful to think about short-term and medium-term versus long-term goals for research. I think with all these PFAS, we will not have the data even shortly after Christmas, even if we wanted to give it to you in EFSA. So I think as a starting point, it can help us to have a better understanding of the uses of the PFAS, the sources, and the volumes. Here, the universal PFAS restriction can help us, but I think also AI actually is actually quite helpful these days in figuring out what is being used where. I fully agree expanding the analytical space is really a need, and I think we can already get on with that. Focus on the neutral compounds, the cationics, the volatiles, and the polymers, and maybe also the transformation products that then in turn will help us to understand the environmental fate of the compounds. Looking at emissions, I think is very useful because it helps us identify some of the compounds that can be very hard to identify at low levels when they're out in the environment. And then I think in the short term, we also need data gap filling methods, as I've said, and maybe just to begin with the MAF, the mixture allocation factor, it has been proposed because it fills a gap while we are waiting for the data. In the long term, I think the modes of action would really be very much welcome, both to understand PFAS, but also to understand how they may affect the toxicities of other compounds. I mean, mixture toxicities. We know they affect the cell membrane. That is very important for uptake and transport of other compounds as well. And I really like the idea that was proposed that maybe we should focus not just on the persistent PFAS, but maybe more broadly on other persistent compounds that we know are quite present in humans, but also tend to accumulate. So that would be my wish list. Thank you.
So thank you very much. Again, any other panelist who wants to add or stress something out?
Yeah, maybe one point to jump in among all these research needs related to PFAS. I think PFAS are persistent contaminants, and they are part of the fact that our planet, our Earth, is not yet pollutant-free. And I think now, of course, there is this high media community attention driven on PFAS, but in fact, PFAS are not alone. There are others, dioxins we have taken care of, heavy metals, and so on. And my fear is that maybe if we devote that much attention on PFAS, that we forget the other ones. And so along the path, along the road, and that's also what maybe Xenia mentioned about, are there synergy, cooperation between these contaminants? I think it should be kept in mind that we must be in a situation where we can highlight where are the priorities in terms of persistent contamination, beyond PFAS. And that's, I think, one of the challenges we do have, because PFAS will be there for a long time, but they are not alone to be there long.
Yeah, thank you. Yeah, Frans?
Well, maybe on a lower scientific level, what I think is important also for our regulation in feed and food is indeed to have, I would say, routine methods of analysis, because because now it's possible to analyze, but it's quite complex, quite also expensive, and so this has automatically a consequence on the number of analyses performed in a routine basis, in a control basis. So I think it's important to have reliable routine methods of analysis, and also, if possible, also very reliable screening methods, which are indeed can be applied on a large number of consignments, so which would indeed build us on a basis of real levels of PFAS in feed, in food, and so which would then be the basis for further regulation on these commodities. Thank you.
Thank you. Xenia, I see your hand up again.
It's a response to Frans, because I think you're absolutely right that these analytical strategies that allows us to test more frequently in more products with routine methods, but also with screening methods, is most needed. And actually, it brings my mind to in the recent proposal for in the Soil Monitoring and Resilience Directive, in the project that I'm leading, Aragon, we put in a suggestion of how you can increase the analysis space for PFAS by looking at the common degradation products, as was previously mentioned, but looking at degradation products that can be analyzed by routine methods like LCMS, where you actually can add a lot of compounds, I mean hundreds of compounds, without substantially increasing the cost. So I think looking at the common degradation products, or maybe marker compounds, that signifies the presence of a compound group. It could be for fluorotelomers, you can look at some FTCA degradation products. That may actually help us to get a better overview without being very costly for the countries. The screening methods that look for total amounts of something, whether it's organochlorine or bromine or metals, or organofluorine in this case, I think would also be very helpful to get a better understanding of, are we covering the chemical space without costing a fortune? So I would very much support that in the meantime while we're waiting for standards.
Thank you. You have Carlos and then Jorge.
Mine is just very quickly, because I also thought I would be doing a disservice to being also a wildlife researcher as my background, to remind everyone here, of course, that environment, we keep talking of human impact for human health and so on, but environment is much more just where the place where the PFAS ends. It's a full ecosystem, and it was a picture from Xenia as well, showing how little known we know about, for example, wildlife, and what some of these compounds can do into a biodiversity that we need to protect. And I think here is where One Health also sells well as a solution for this topic, because combining these data collections and the knowledge we have in these species, we get a better picture, will help to regulate for the purposes of humans and environment, but will actually protect a lot more. And I think it's important to keep this, I saw the little deer there, reindeer or a moose there in the picture for her, and this reminded me that as a wildlife researcher, guys, PFAS also gets in them. So let's also think a little about these guys. That was...
Okay. Jorge?
Yes, really on the broader perspective, if we want to get rid of PFAS, we have to go to alternatives. So we have to be sure that we not go in the path of regrettable substitution. So the safe and sustainable development methods, I think they should be promoted and, well, upfront in that perspective. So another challenge, a bit outside the scope of this conference, but related.
Jorge wanted to add something?
Yes, first, as a response to Carlos, I assume that this is like one of the purpose of the workshop on the 17th of November from EFSA to join like EEA, ECHA, and WHO, EFSA, and the European agencies. There is one.
Just because everyone has advertised my workshop already, so that's good. I don't need to do the job. But indeed, the idea on the 17 is, I think you've set amazingly well the scene here about some of the challenges and some of the knowledge. 17 is to go a little deeper in what we actually can do and cannot do right now in risk assessment. And we are indeed trying to bring the entire community that is linked to this, whether they are on the human side, on the environmental side, on the EU, or on the WHO side, which, as you know, is also working on the topic, coming out now with phase 2 of their PFAS adventure, which hopefully will not diverge from ours. So 17th of January, you can register. It's of November, 17th of November, afternoon. It's open, the registration, online. Everyone is welcome. And yes, Jorge, let's see if we can team up a little better in how we do risk assessment. So I've done my pitch.
Thanks a lot. Little wish I would have, that's looking on the last Nobel Prize, perhaps we can build some organometallic structures to clean up wastewater or other things from PFAS. How about that? And I see Jorge wants to say something.
Yeah, and at the same time, while we are sitting here and talking about solving the problems, there is a huge cluster of chemists here in Berlin who are generating the PFAS of the future. And now we do have contact with them. For many years, we were two communities that were completely separate. So they're researching what new PFAS they can make.
So thank you. I think we have to stop with the discussion, but I think perhaps we do a last little round and see what each of your take-home message of this conference is. So I don't know who wants perhaps to start on the other side this time, Frans?
I think the main message that I have from the conference is we have already gone away, but we have still a very long way to go on PFAS.
Jorge?
Instead of trying to wrap up everything, I'm going to look at a very specific topic that was touched here, which was the toxicokinetics in humans and animals. And I was impressed by the amount of new detail that we now understand and how we're moving into mechanistic models and understanding more and more of the details, which will help us in the big picture. This toxicokinetics is essential to understand the problem. Not sufficient, but necessary.
Okay.
I think the main message of this conference, but also the last 10 years, is that when we work together, I said it before, we can go a long way, and we have to continue doing this, sharing information, sharing data, improving our work.
Matthieu?
Just to make it in a nutshell, I feel like we have two key challenges. The first one is stopping new PFAS to come to the environment, and that's the end of the restriction process. And it's not yet finished, and it's important for it to go to the end. And at the same time, there are PFAS already in the environment, and also that will come to the environment until this restriction process has gone. And then there we have to be smart, because the combination of the number of substances is huge. And of course, we have to do at the same time use our usual tools, toxicology, epidemiology, and so on, but also find smarter ways in order to avoid to be surprised by some of the ugly PFAS we haven't identified yet.
Thank you. Carlos?
I think what resonates to me from today and from the topic, to me and to my colleagues back in Parma, is that it is challenging, it's complex, and it can be confusing. But for these 3 C's, we have another 3 that can help us. And that is really more collaboration, more capacity building, and definitely more communication. So with those 3 C's, I'm confident we will sort out the first ones.
Thank you. And Xenia, last but not least.
Has been said, and I once again I really regret that I was not part of this conference to hear all the new developments in toxicology. But I would fully agree the PFAS, they are persistent once we use them and emit them into the environment, they're extremely difficult to get rid of. We have a pre-polluted environment, so we have to stop using them. The risk is out there, whether we measure it or not. The body doesn't care if we have measured it. We will be exposed to whatever we have in our blood. So I think this expansion of the analytical space is really needed, but I think we have to take a strategic approach to which PFAS we analyze, those that are used the most, those that are most likely to be harmful. And we need to analyze them in areas where they're most likely to be a problem. So I think we really need prioritization. And in the meantime, I think we need to have some data gap filling methods so we do not ignore the ones that we don't have. And then I really hope that we will get a common repository of chemical standards so we as analytical chemists can help you produce better data for the future. Thank you.
So, thank you a lot. So then we are at the end of the discussion. I want to thank all the panelists here on site, but of course also in India. Thank you for taking your time to connect to us. I want to thank to all of you for your attention. But the last words on the discussion will have somebody else. Lorna Schütte is sitting here in the room and she was illustrating the discussion. So she will, in a minute, she will show us the picture she illustrated and explain it a little bit. And after that, the last words of the conference will be given by Teve Stralau, the Vice President of the BFR. I was assured that he won't take the 20 minutes, so we will make it more or less in time. So, Lorna Schütte, the floor is yours.
Thank you so much. I hope you can hear me, and I've already connected my iPad, so I hope that soon you will also see it. Perfect. Okay, so this is what I've drawn from this discussion, and I'm just going to quickly summarize what I've drawn so that you can later on explore it in detail. We started on the left side, so it goes around this person in the middle, which is taken from the program, as you probably see. So in the beginning, you were asked, what are the most pressing challenges? And then, so I put down some of the things that you said. For example, do we have the science to get the job done on the bottom? Which PFAS are used where? The movement of the PFAS in the food chain, translating the knowledge, connecting the data, but also teaming up in this challenge. And also, yeah, is there a common, I called it an end PFAS for the result when it, develops, sort of. And then you talked about the that there are too many PFAS overall, and there's needed a new data use, for example, data pooling, that you don't lose the research findings in these lost cabinets, and connect all the data on that you have. I've also included here the different research ideas that you mentioned, for example, on short and long-term effects, also the use of AI, the effect on other compounds and new methodologies. And then you also talked about the animal studies, which are, as far as I understood, the best models that you have so far, but there's also the need to strengthen and broaden this knowledge, the need to create the standards and routine methods and screening, which can also reduce cost. And then you talked about the combined information to understand the risk better, also including the environment, investigating closer to the sources, also the impact on the environment. I tried to include also a moose here for the effect here. You talked about the levels of feed and the levels in food, which of course correspond, but there's more data needed. Both need to be as low as reasonable, but there's this correspondence. And then you also talked about the risk communication with people, well, telling people not to eat the eggs at Easter is, well, could be a problem, but on the other side, telling them later could also be a problem. So there needs to be a connection with the social sciences, to also communicate what consumers can do in a united message. And yeah, I've included this like being on the same boat, sort of, this is where we're going, and then taking people with you so they understand what you're doing and what is needed for this risk management. In the middle, I've also included the very short answers you gave to the last question, so that's a long way to go. You need to work together and share the knowledge, and then I've also wanted to include the very last point that was mentioned just now. There is the risk out there, whether we measure it or not, to finish up this image. Thank you so much for your attention listening to me.
Yeah, thank you, Lorna. And as I said, the last words will be given by Tevis Stralau.
Yeah, thank you. As announced already, I will try to make it short. When I was asked to conclude this conference, dear ladies and gentlemen, dear colleagues, dear national and international guests, I thought that's going to be difficult because it's going to be a difficult topic. And actually, after having listened now to the panel discussion, I could just step away and say, okay, everything was said here. PFAS is one of the big current challenges of regulation, but I think actually it's exemplary for the challenges that we will face in the future, because when you listen carefully to the 24 presentations and the 33 posters, you realize that while we will all definitely agree that we have to regulate them, the issue is how do we regulate them? We don't even know yet how to measure them consistently. I mean, it starts with exposure, it starts with the levels that we have inside, with the differences. We heard that there are huge discrepancies when in the uptake, depending on the foods you're looking at, on the consumer groups you're looking at, on the demographic groups you're looking at. And then at the same time, we have to realize that while we want to get rid of all PFAS, we won't be able to do that because they're quite essential substances in terms of technological features and advances. And if I hear that we have to substitute them, I always think of, yeah, actually, if you look at the periodic table, there are not many substances that can substitute that chemically. And if you look at those substances, I really, really doubt that they have that much more favorable features. So that's going to be a real challenge. And that is one of the reasons why the research on PFAS is that large and why it is so difficult to get a grasp on this whole group. Because if you look at the kinetics, if you look at the toxicological properties, they're quite diverse as well. Even when you look at the persistence, there are huge differences. And we won't be able to do PFAS spiked muffins for all of them. And I doubt that this would be acceptable. We need that as a basis for the kinetic models that we have, but it is a challenge if we want to get a good regulation on that. And when EFSA published the opinion on PFAS in 2020, there was significant progress in the aftermath being made on PFAS research with contributions from the fields of analytics, toxicology, kinetics, epidemiology, and so on. And so in the moment we are in a much better situation to basically understand the problem, see what we can do about it, but it is still a long way to go until we have a solution. And I'm pretty sure once we have that solution, we will still be in a position that we probably have to adjust it in the aftermath and then think of how we proceed in the future. And that's only one group. I mean, it was mentioned before, we have lots of other groups that are similar in terms of the size of the group and the properties. So we think we made huge progress within this conference, and I think actually the conference came just at the right time because reports have been published by ECHA. The SEAC and the RAC have given their first statements, and I think if it was ever the time to summarize that up and add some to the features, add some more data to that, it's probably now. Even if we are going to continue with the research on that. We also heard that it is difficult to get a grasp not only on the exposure, but also on the toxicity. I think we saw that PFAS, depending on what PFAS you're looking at, have different toxicological properties. There is some grasp, and that's what makes it toxicologically interesting, that one of the main endpoints is immunotoxicity, though we don't really understand how and why. And I think that's something that's going to trouble us for some while, because immunotoxicity in general is one of those endpoints that really is very elusive in terms of toxicological testing and so on. We basically only understand sensitization very well. Everything else is difficult to get a quantitative measure onto it. And we got the highlight that the real other issue that we have to tackle in terms of PFAS, and I again would say that's true for many of the regulatory problems we have, is communication. It's not only the communication amongst us and amongst the different disciplines in science, but it's also to the public, and that communication has to change depending on whom you address and at what stage of the process you are actually. The Easter eggs are a perfect example. And I think the other issue, the underlying issue there is that if you live in times where there is an expectation of no risk, and this expectation is out there, you always have a problem when you tell people, actually there is a risk and we won't be able to get rid of it completely and you won't be able to avoid it completely. So then you have to give advice, you have to basically enable people to judge and grasp the risk in order to get to terms with it. And I think that is something where we still can do better in the future with all our communications, because many of the issues we actually face are normally communicative issues, not really the scientific or toxicological issues. Normally we more or less have the same opinion on those issues. And so my thanks in the end, with the outlook that we probably will have something to work with once the restriction is out there. My special thanks go to all the speakers that made this conference happen, to the national and international guests that came here and took a long way and took the difficulties, part of them, to travel with the airlines that don't work everywhere as nicely as they should, and I don't want to mention Deutsche Bahn. And of course, I want to thank the working group here at BFR and the organizing team and our PFAS working group. And I know there were many people involved, and I won't read them out all. That always would be not fair to a single one of them. But I think I want to give at least the main person, the main face, some flowers. So for Janine Kowalczyk. Thank you so much. It was her work that made much of this possible in the organizing team and everything else. And I think, yeah, you probably have to take a picture and send it to everyone else who was involved. Thank you so much.
Very much.
And thanks to all of you who basically came here and made this conference work, because it's not only the speakers and the posters that are necessary to get a good conference, it's also the people contributing to it, keeping the discussions alive, and without them it wouldn't be possible. So thanks to all of you as well.